Hi. So in this video, I'm going to do another method of differentiating. We're getting close to the end of all the different methods. And this one it's just a way of making the question easier. You don't have to do it this way. However, sometimes in the exam it will say differentiate by logarithmic differentiation. So in terms of that way, you will have to do it. And it can make the question easier to differentiate if it is involving complicated powers, roots, or functions like that. Okay, and the first step, and which is why it's called logarithmic differentiation, is to just take the natural logarithm of both sides. Okay, so take logs, and so I'm going to take the natural log, and hopefully you remember your logs rules from higher, because then that means it's just x plus 3 log 2. Okay, which we could then break it out and get x log 2 plus 3 log 2. I have not changed the overall value of this equation, this function. However, now we can hopefully see that it is a very easily straightforward, no, I can't say that properly, it is a straightforward to differentiate function by implicit differentiation. Okay, so d by dx of log y, d by dx of x log 2 plus d by dx of 3 log 2. Derivative of log y is going to be 1 over y dy by dx. Derivative of x log 2 is just going to be log 2. Think of it as a number. Log 2 is just a number, x is a term, so it's just like log 2 x, so it's just like 5x. Derivative of 5x would be 5, so derivative of log 2x would just be log 2. And then the same goes for this. This is just a constant, so it just disappears. So we get dy by dx equals y log 2. It's not really convenient to have it in terms of y, but we know that y equals 2 to the power x plus 3. And that's a differentiated, which is a lot easier than if you'd done it in a more different way. Okay, so do another one. First thing, take logs. So we get ln y equals ln x to the x ln x. So it's getting a bit more complicated. So it's going to be the derivative of log y of x log x. So derivative of log y, 1 over y dy by dx. And then it's just product rule. Okay, so differentiate the first, leave the second. Leave the first, differentiate the second. So we get 1 over y dy by dx equals, they cancel out, so, or they simplify, so it's just log x plus 1. So dy by dx equals y times all of that. And we know that y is x to the power of x. Last one. Firstly, it's f of x, but all we do is let it equal y, let f of x equal y, and take logs. So we get y equals e to the sine squared x. So we get log y equals log of e to the sine squared x. Log of e is just 1. So it's a derivative of log y and the derivative of sine squared x, which is 1 over y dy by dx. Differentiate that and you get 2 bracket sine x times derivative inside the bracket, which is cos x. So we get y 2 sine x cos x, and then we replace the y with the e to the sine squared x. So we get 2 sine x cos x e to the sine squared x. Okay, so that is logarithmic differentiation, and it is a method in which we can make a function easier to differentiate if there are complicated powers involved.